Welcome to the Rocks of Utah. My name is Benjamin Berger, and today I'm exploring a remote region of central Utah and hiking through a major uplift of Triassic rock layers into the Great San Rafael Swell, into the famous red rock landscape of Utah's Sinbad country. The end Permian mass extinction that occurred 252 million years ago is colloquially referred to as the Great Dying. And it's been tied to the combustion of thick deposits of coal and other hydrocarbon-rich rocks during the large volcanic eruptions of the Siberian Traps, releasing an immense quantity of air pollutants, including carbon dioxide, sulfur dioxide, and mercury into the atmosphere. Now, these gases contributed to significant global warming, as well as completely changing the chemistry of the world's oceans, resulting in acidic and less oxygenated ocean waters. The mass extinction event bears many frightening similarities with modern anthropogenic global warming of today. So I have this lingering scientific question regarding how marine life recovered from this event. And these questions can really only be answered by studying the fossilized remains of animals that survived and later flourished in the oceans during the early Triassic period. What types of life flourished in these early Triassic oceans? Which types of animals recovered from the mass extinction event first? And which ones just never really fully recovered from the event? These towering rock layers behind me were heaved up during a great mountain building event during the late Cretaceous and early Paleocene, which saw the rise of the Colorado Plateau to the southwest and the southern Rocky Mountains to the west. But here in central Utah, the uplift resulted in a dome or anticline feature that rises above the earth. This uplift, while dramatic, was not the result of volcanic activity, but was pushed up from deep down in Earth's interior through regional basement rock involvement that is unique to the American West. And it links this event to the Laramide orogeny that gave us the southern Rocky Mountains of Colorado. In Utah, these walls of sandstone are called a reef on many topographic maps, such as Capitol Reef, which is just to the south. They're not true reefs in the marine sense, but they are sandstones of resistant layers that, because of the abundance of quartz crystals within these rocks, form weather-resistant layers that rise up like the ridges on an elephant's tooth from the desert. These uplifted rock layers were worn down through millions of years of erosion, exposing the resistant sandstones that rise from the vast desert region around me. Now, these sandstones are the massive cliffs of the Triassic, late Triassic, early Jurassic Navajo sandstone. It's a widespread layer of fossilized sand dunes that existed here in Utah 200 million years ago. But today I'm interested in what lays below this layer of sandstone, much deeper in the center of the swell. And for that, we need to hike through Black Dragon Canyon. Black Dragon Canyon is one of the many canyons that forge a path through these rocks along the towering ridge of sandstones that act as a great wall. There's some really amazing petroglyphs in Black Dragon Canyon, and you can see some of those up here. These have been interpreted as being Hopi petroglyphs, and you can see that they're actually painted on with two different colors. We got the iron oxides red, and we got the sort of charcoal black that have been painted on. And if you look at them, they look very like they're interpreting growing corn and different crops. You can actually see some circles in here, like they're representing maybe calendars of when to plant and harvest food. These are really intricate, and they're using two colors that are painted on. There's some older ones over here that they're a little bit more faded. One of those has been interpreted as being a dragon, and that's a black dragon, although looking at it, actually it's kind of a reddish dragon. Some people have interpreted it as a pterodactyl, but actually I think what the consensus is that it might actually be a snake. So this is a fantastic view of the Triassic. So up there's the Navajo Sandstone, the Chinle Formation, about down here where it gets bedded in the red beds is the Moenkopi, the upper member of the Moenkopi. And then this kind of lighter color stuff in the foreground is the Sinbad limestone, and getting into that layer. So quite a bit of the Triassic is exposed in these outcrops. It's hard to see this right here, but there's a gastropod, a little snail fossil right there. Look at this, it's just full of fossils. That's incredible. Look at that. All right, so I pulled out this rock that I was looking at. That is something colonial, but I don't think it is. So what this is that I think there's a layer of calcium carbonate, like an algal mat, more like a stromatolite type feature that's been laid down, maybe by an algae like a cyanobacteria. But then there's these holes that are in it. And I think what these are actually little burrows. So organisms are burrowing into this hard substrate. And it gives it the appearance of a coral, even though it's not a coral. So it caught my eye because it looks it's very organic looking, and that's because it is. but it's in this limestone. So this limestone, the Sinbad limestone, is chock full of life, but this doesn't look like a coral reef. In fact, most of this limestone is composed of bivalves for the most part. And I'm trying to find some ammonites. But I wanted to get this out so I could take a look at it real closely, but I think that's what it is. It took me forever to get this. This limestone's really hard. But you can see those little burrows in there, so there's definitely a lot of life in this limestone. Look at this shale right here. It's really big. This stuff is just full. Just completely full of fossils. Look at all the shells. It's incredible. Look at them all. Let's see if I can get more of that exposed. Some really nice pieces in here. Yeah, look at that. There we go, we found an ammonite. So let me show it to you. It's pretty easy to see. Get it into focus. You can see it right here. Yay! We found an ammonite. They are here. Early Triassic ammonite. And it's in this giant, huge block. That's how it always is. Alright, I think I've got something here that looks interesting. It's fossil for sure. Can't tell if it's a gastropod or if it's an ammonoid. Looks to me like a gastropod. You can see the swirl and it's not symmetrical. I can do some prep work on this. These fossils that I've been finding have been well studied as the world was still recovering from Earth's worst mass extinction. So they represent the survivors. I've become fascinated in understanding this recovery period in Earth's history. Recently, there's been some debate in science regarding what followed. Some researchers have argued that the recovery was remarkably a quick period with rapid and swift full recovery of biodiversity within less than 1 million years after the world's worst mass extinction event. While others have suggested a much longer, more protracted recovery interval, with faunas not really fully recovering until later in the Triassic to something around 247 million years ago. That's 5 million years afterward. The early Triassic has historically been called the Scythian, and it's more recently been divided into the older Undian and the younger Olecian. Now, these further ages are further divided into smaller sort of sub-ages, the Induan into the Jesbacian and the Dianirian, and the younger Olecian into the Smithian and Spathian ages. The beginning of the Smithian has been recently dated to around 251.2 million years, which is only 700,000 years after the end Permian extinction. Now, geologists have been able to subdivide these time periods into narrow intervals of time because of the stepwise first appearances of new marine animals in the fossil record. Mostly the recovery of ammonites that would go on to dominate the Triassic oceans. It was also a time of continued perturbations to the ecosystems, as there's a well-recognized additional mass extinction between the Smithian and Spathian boundaries in the early Triassic period as well. The Triassic Moenkopi formation or group represents this wide span of time in Utah of the later Smithian and Spathian subages. It's a red layer of thin shales and mudstones laid down along the tidal flats of the Palaskian Ocean, along the coastline of the far western region of Pangaea, the great supercontinent that once held all the continents together. This is really cool. This is along the road, and it's waves, ripple marks from the shallow marine, sort of near shore tidal flat sort of deposits that we see in the Moenkopi and in the Sinbad here. As we get down, this is in the sandstone. So this means it's shallow enough for wave base to be creating these ripples. So very shallow sea. We're hoping to get into more deeper areas so we can get into finding more fossils. During a major advancement or transgression of the ocean eastward, a layer of limestone was left behind in the Moenkopi Formation called the Sinbad limestone. Now, this layer of limestone has been correlated from central Utah to rock layers near Nevada and north into Idaho, known as the Thames limestone. Now, I've come here following the work of Margaret Fraser, who worked in these rock layers in detail about 20 years ago, discovering an abundance of bivalves and microgastropods. These are tiny fossilized snail shells along this ancient shallow sea. But she also reported on other fossils, including echinoderms, scaphopods, and encrusting foraminifera, and some ammonoids, as well as trace fossils. I'm curious to examine these rock layers and compare them to the deep marine environment of the Thames limestone further from shore in western Utah, as well as trying to understand how these rock layers compare to the older Dinwoody and Moenkopi formations in northern Utah. A more recent paper describing the ammonoids from the Sinbad limestone indicate that the rock layer is deposited in the Smithian subage around 251 million years ago, or about 900,000 years after the mass extinction event, but before the next extinction at the Smithian-Spathian boundary. It's a good place to visit to see how Earth recovered from the mass extinction only 900 centuries afterward. Gastropods, or fossilized snails, are common in this layer of limestone. They initially were thought to be small and diminutive, freakishly small, as they recovered from the mass extinction. In paleontology, this is called the Lilliput effect, or the Lilliputian effect, from the tiny people in the story of Gulliver's Travels. However, recent census of the sizes of these gastropods suggests that they were normal size, but the Sinbad limestone gastropods may have been small due to the shallow marine environment that it represents, rather than necessarily because of the recovery from the mass extinction. One of the reasons that I wanted to come to this place was to see these fossils. Well, also to maybe appreciate the strength of Earth's ability to recover from mass extinctions, and for life to continue onward into the future despite what's thrown at it. The early Triassic period was a strange period on Earth, but it was not completely barren and inhospitable. Life still flourished, and it found a way to survive and move on to even more fantastic era. The great Mesozoic with its dinosaurs and great revolutions in plant life that were to come. These fossils were proof that life moves on from disaster and that recovery is possible. So I'm out here in the middle of a field full of wildflowers looking for fossils. No cell service out here. It's just really nice to be in a remote place like this and just spending some time looking for fossils and seeing what I can find and studying a little bit of the geology. I think that's one of the things I really like about geology and paleontology is that you come out to places like this that are very remote and you just explore and try to figure out what's going on with the rocks and understanding how the environment's changed through time. And it's just really incredible when you think about it, like how life was able to come back from this devastating mass extinction within a fairly short period of time.